Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is pH CH2CH D CH3, where the central carbon bears a deuterium D, a hydrogen, implicitly, a benzyl group PHCH2, and a methyl group. The central carbon C2 already has 4 different substituents T, H, wait, actually C2 has D, CH3, PHCH2 and. Let us re-examine. C2 bears D, CH3, CH2PH, and H, making it a chiral center with 4 different groups. Moving on to the next step. Identify sites of free radical bromination under Br to HV. Free radical bromination is selective for the most stable, weakest CH bond position. The benzylic position, PHCH2, is the most activated site for radical bromination due to resonance stabilization of the benzylic radical. The C2 position also has a CH and C2D bond, but benzylic CH is preferentially abstracted. Moving on to the next step. Bromination at the benzylic carbon, C1PHCH2. The benzylic carbon, PHCH2, has 2 equivalent hydrogens. Abstraction of 1H gives a benzylic radical at C1, PHCH, CH, D, CH3. This radical carbon, C1, becomes a new chiral center upon bromine capture. It will have PH, Br, H, and CH, D, CH3 as substituents. And for the final step, C2 is already a stereocenter bearing D, H, CH3, CH2PH. The radical at C1 is planar, sp2, so Br can attack from either face with roughly equal probability, generating both R and S configurations at C1. The product PHCH-BrCH, D, CH3 has 2 stereocenters, C1, PH, Br, H, CH, D, CH3, and C2, D, H, CH3, CHBrPH. The original C2 stereochemistry is retained. Radical reaction does not disturb C2. Since C1 is formed with equal probability of R and S, planar radical, we get 2 products, R, C2 config, and S, C2 config. These 2 products are non-superimposable, non-mirror image stereoisomers of each other. They are diastereomers, one specific enantiomer at C2 combined with R at C1 and the same enantiomer at C2 combined with S at C1. They are not a racemic mixture because they are not enantiomers of each other. They differ at only one of 2 stereocenters. They are not meso because the molecule lacks the requisite internal symmetry. They are not constitutional isomers because they have the same connectivity. A racemic mixture would require 2 enantiomers, mirror images. The 2 products here share the same configuration at C2 but differ at C1, so they are diastereomers, not enantiomers. Meso requires an internal plane of symmetry. The presence of deuterium and the unsymmetrical substitution pattern prevents this. Therefore, the correct answer is A. Therefore, the correct answer is option A.